Now, when we talk about computer vision techniques, now if a computer is looking at an image of a car, now how will it identify that that car is there particularly in which area or in which region of the image? Now that is the something by the help of called edge detection. Edge detection technique actually allows the computer to identify the shape of an object in an image. So when a car is shown in an image and there is some background, so if the color of the car is different from the background, then the difference between the pixels which are representing color and the difference between the pixels of the car, wherever they are meeting, that particular meeting point is called edge. So when the computer is detecting the pixel color around the car, it will come to know when the background has started and when the car is beginning by making out the difference between the intensities or sudden color change or sudden intensity change between the two adjacent pixels. And if it is moving in a particular direction, either vertical or horizontal, if it is moving, suppose vertical across an edge, so the pixels which are representing the edge are of the same intensity. So the computer can figure, okay, this looks like an edge. Similarly, horizontal. So when you move a detection window, when you are detecting the pixel, when the computer is detecting the pixels, wherever there is a sudden change in the intensity of the pixel, that gives a hint to the computer that this particular point could be an edge. And across that, the edges are detected in entire image. One of the technique is, one of the algorithm is called Sobel algorithm or Sobel filter. So we will see how the filters are applied to detect the edges in the image. So Sobel filter is very popular and it is used to quickly identify edges horizontally and vertically in an image. Similarly, there is another popular filter is Purvitt filter. It can also figure out whether the image has been rotated or not. If you rotate the image, it can figure that rotated image and the actual image are same. So Purvitt filter is very useful when image orientation is in concern. And then sometimes what happens is edges are not always vertically at right angle or horizontally at right angle. They could be at diagonal also. So for diagonal edge detection, there is Robert filter, which is commonly used. So these are the filters which are used commonly in detecting the edges. Then other than edges, there are corners. Corners are always formed when two edges cross each other. So that crossing point actually gives the hint of a corner. So if detection of a vertical edge and a detection of a horizontal edge is happening, and during that movement, during that detection, if the sudden change in the intensity of the pixel is happening in vertical direction also and in horizontal direction also, then it gives the hint to the computer that this could be a corner. So corners are detected. These are also helpful in figuring out, in making out the shape of an object in the image. Then if the computer is detecting the pixels in the image and for a longer period of duration, for a longer distance across the pixels, there is no change in intensity, or there is very less change in the intensity of the pixels, then that area is neither an edge, it cannot be a corner, it cannot be a line or a curve. It is a plane area. Such plane areas are called blobs, like a flat surface. So how this edge detection and all that helps in processing the image for computer vision, for classification of the images, for identifying the objects in the images. This is done with the help of something called convolution neural network. So we will look at this in detail now. So far what we have seen is, in this first part of the session, we have just looked at how image processing is different from computer vision, what actually computer vision is, what is the purpose or the application of computer vision, and what actually computer vision does. Computer vision identifies the objects by identifying the edges, by identifying the corners, to figure the shape of an object inside the image. And one very important thing we learned is that for us, what is an image is a set of numbers for computers. What happens is when we talk about an image which is given to a computer for computer vision purpose, for say identification of the image or identification of an object in an image. Now that image is a set of numbers. That image is converted into a grayscale image so that it has only one plane and only two dimensions are there, height and width, and that direct dimension of pixel is given to the computer. Now what computer does is it takes another set of numbers. That set of numbers is actually a 2D array which is very small as compared to the actual image. Actual image could there could be thousands of pixels, but that particular filter might be having hundreds of pixels. For example, here I have taken this concept to conceptualize this particular thing. Here we are assuming that this is an image of how many pixels? 6 by 6 pixels. Only 36 pixels are there. Now in these 36 pixels, there are two colors only, gray and black. Now this is a 36 pixel image and computer has another set of numbers which is only 3 by 3, that is 9 pixels. So there is a grid of 9 numbers and there is a grid of 36 numbers over here. Now what computer does is it takes up, first of all, the first 9 pixels like this from the very top left corner of the image. See, there are also the 9. This window which is red colored is the actual size of this particular small array. So it considers the first 9 pixels here, and what it does is it multiplies the first pixel here with the first pixel in this small array, the second one with the second one, the third one with the third one, and then the first pixel of the second row with the first pixel of the second row in the small array, and so on. It multiplies these corresponding values, and whatever multiplications, whatever products come, they all are added together and one single number is generated. That single number is taken like this separately here as I show you here. So if I'm processing all these numbers, all these 9 numbers here and 9 numbers here multiplied together and their sum is taken, here it is giving me 0. After that, what happens? This window gets shifted to the next 9 pixels like this. See, a pixel shift has happened. And again, the same operation is performed now on those pixels which are now in this window. Again, this happens. It is giving me minus 36. It is kept here. And then until the pixels in the last window like this. This is the first window. This is the first 9 pixels. Whatever multiplication, whatever is the sum of the multiplication of these two corresponding numbers, that sum which is 0, it is always kept in the center location of the window. This center location is this. And when the window moves to the next 9 pixels, this is the center. See? When we move further, now this is the center. So a separate grid of 4 by 4 is created and this is the resultant. And as you see here, these numbers which are together, which are similar, they are giving the hint to the computer that this could be an edge. See this is an image, this is an edge, and here this set compared with this set, and that is why computer gets to know that this could be an edge. And this small array which is used to multiply over the pixels, which is used to multiply with the pixels of the actual image, this grid is called filter or kernel. Now, this process of moving the window over the pixels and multiplying the pixels one by one after a shift, this process is called convolution. So convolution is happened by the help of a filter, and by the sum of multiplication, we take out the feature of an image. This is called feature extraction. Feature, what is the feature of an image? The feature of an image could be color, the intensity of the pixel, basically the intensity of the pixel, the position of the pixel. So these are called features of an image. And this feature extraction is done by this technique. And the resultant values are interpreted by the computer to detect whether it is an edge, corner, or a curve. And this tells the computer that what could be the proper shape emerging in an image of a car or of a fruit or a face. Or the distance between the 2 points also is a feature. So there are several features which are extracted by the computer by convolution by the help of a filter.